Oh yeah, let's go. Hey, we're doing Algebra 3, Cyber Day today. Hope you're having a fantastic day with all the snow and winter weather and frolicking through the meadows. Yes. So today, I know that right now you're probably thinking, oh my goodness, we have math today? Seriously? Cyber Day, and I know that they're probably that way for a lot of other classes, but actually today it's pretty simple. Okay, the objectives are very simple. Two things. Number one, make sure that you finish your review. Okay, flat out finish the review. Some of you got like 4 or 5 problems done. Remember, there's 18 total, so finish your review. That's step number one. Okay, step number two is to be able to watch this video, be able to come up with maybe some problems that I could help you with that could aid you in that review process. So in watching the video, hopefully it's allowing you to review, and hopefully allows you to review for that test that's Friday and Monday. Logistically, we're going to touch base on what that'll look like in the future. If we are in school tomorrow, then the game plan is to continue with what we did, and that's have the tests on Friday, Monday. If for some reason that changes, I will let you know as soon as possible. All right. As we begin, just remember that I'm going to kind of screen share this. The review looks something like this. Okay, remember that? That's what the review looks like. Also remember that the answer sheet can actually be found on the following website. Let me make sure. I think it should show at the top, algebra3gac4.weebly.com. It should show it right up at the top. Remember, the review sheet's right here. Here's the answer sheet. And then that trigonometry review, you can actually watch another video if you need it right down below. Okay, so video and then the answer sheet and then also the review if you had forgotten it or didn't get it in that way. All right? All right. Also, I want to touch base with you on a couple of logistics regarding some problems that I feel as though we may have some struggles on. And the ones that I feel as though we might have the most struggle on, let me get that up here. Here we go. Are numbers 8, 12, 18, 10, and 14. So as we go forward, I want to make sure we just touch base on one of them. And then after doing that, hopefully you have an idea of what we're doing going forward. All right, so let's start with number 8. First of all, it states that there's 5/2 sine of 2x plus pi over 2. Well, I don't think there's anyone and their sister that wouldn't be able to figure out what the amplitude is, right? So 5/2 and negative 5/2 is what we're looking for. But here's where the tough part comes in, because now if we have values that are maybe half or quarter or even a third, that's when we can have a little difficulty there, and that's where we're at. So remember, with this, we're going to find what our period and our phase shift is. Our period we can find by doing 2 pi over b, where our phase shift can be found if we did c over b. So if we did 2 pi over b, b is 2, so 2 pi over 2 would be reduced down to pi. So again, remember the distance that we travel from the start to the finish will be a distance or a length of pi. Remember, with our phase shift is c over b, where c is pi over 2 and b is 2 over 1. Again, remember that has imaginary 1 over it. If we're dividing, we kind of flip it to the top to get pi over 2 multiplied by 1/2. Okay? So now if I were to multiply this together, I will end up getting pi over 4 as my starting point. But because this is positive here, remind yourselves that the opposite is true, where if it's positive, you're going to go to the left, so it'll be negative, where if it was negative, it would move to the right. So remember, my phase shift is my starting point, whereas my period is not my end point, but it's the distance that I travel from my start point. So if I start at negative pi over 4, I must travel a distance of pi. So if you didn't really know how to do it, you could take negative pi over 4 and add pi to the total, to where if you put a 4 on bottom, you would also put a 4 on top. And then if I combine that together, I would get 3 pi over 4. Now, some of you can do that without looking, and that's A-okay. All right, but that would be my beginning and end. See you, Jakob. Have a good one, man. Beginning and my end, and then I have my middle and both of my quarters, all right? Remember, sine, and I'll kind of graph cosine here. Cosine is where if it was positive, I start at the top, right? And I'll end at the top, and I go through and I'll do it as a dotted line. I go through up, 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 and that's one period, right? Make sure it's not like, don't make it a V. Like some of you actually like go like that with it. No, no, no. Make sure it's curved as you approach it. But again, that's cosine. If I did sine, the only difference now is I go through each of the beginning, middle, and end. So I go up, touch, come through, touch, come up, and back up again. You might have to fix it a little bit, but that's one period. And then if I was to continue one, I know I kind of have the idea of what I would do going forward. So if I continue, I'd go up, down, touch. I just continue that same pattern going up until finally, it should go right here. I would end up right at that spot, all right? So again, phase shift is my starting point, period, is the distance I travel from my starting point, okay? So negative pi over 4, added pi, and that's how I get to my end point there, all right? Now look at the next one. We did 8. Now let's go to the next one, which would be 10. Remember with this one that when the 2 is on the outside of the parentheses, that will be a vertical shift. So that's where it pushes it up or down depending on if it's positive or negative. Also know that in this one it does have a B, but it does not have a C. So make sure you know that going forward. And also when you did the period for number 10, it'd be 2 pi over B, where B is 2 pi. If I were to reduce that, that would actually be only 1. So that's where you would have to take these out and adjust that going forward with what values are on the X. All right, so we've got that one. We're good to go. Now with numbers 12 and 14, you'll notice that they're pretty much the same thing. The only difference is the amplitude change and the tangent and cotangent. Remember with tangent, you set it equal to pi over 2 and negative pi over 2, where cotangent sets it equal to 0 and pi. Okay, and then we'll hit 18 at the very end. So in this example, I have x plus pi over 2 within terms of tangent, and I'll set it equal to pi over 2, and then I'll also set 1 equal to negative pi over 2. Okay? Now when I subtract pi over 2 on both sides, on this one, you'll end up getting x is equal to 0, and on this one, you'll get x is equal to, and if I subtracted pi over 2, be careful not to cancel that. Negative pi over 2 minus pi over 2 is negative pi. All right? If Thomas owes me a pizza here and I subtract, or half a pizza, and then he also owes me another half of a pizza because of how bad he's doing in my class, we know that'll be he owes me, or negative pi is what will be my end point. So we have 0 and negative pi, and remember that we have an asymptote at each of those beginning and ending points. We know the middle's here, and we also know our quarters are here. Now, as I approach this problem, I know that I'm going to rise to the right and fall to the left because it's positive tangent. If it was negative, I'd rise left, fall right, correct? But since I'm rising right at my amplitude will go up right here. We know it's going up, so we know it's going to go up 1. And to my left, and we know it's going to go down 1. Now, don't draw it to where it's some of you draw it kind of different. Remember, it's just like it's a half umbrella down and a half umbrella up. Okay, and that right there will allow us to see, again, that's one period. And then what we'll do is just do another one. Again, we're here, quarter up, quarter down, right there, and oh man, that's where I have an eraser. I can erase that, and we know it'll go up. Okay, remember, if it goes one way, the whole rest of the way, all the way into negative infinity, infinity, it'll keep rising to the right, fall to the left, and it'll look just like that. It should be mirrored all the way across. Now, what's the distance of this period? Well, the distance is pi because one whole tangent graph was occurred from 0 to negative pi. Remember, with tangent, traditionally, the period will be pi, whereas sine and cosine, and even cosecant and secant, traditionally, it'll be 2 pi. All right, now let's see how that compares to cotangent. Remember, cotangent would be x plus pi over 2 set equal to 0 and set equal to pi. Now, when I subtract pi over 2, I should get x is equal to negative pi over 2, and then this one would be x is equal to, this should be pi, I'm sorry. X is equal to negative pi over 2. So now I've got one here, and I've got one in here. Middle, quarters, quarter. All right, because it's cotangent, I rise to the left, so I'm at my quarter, I'm going to rise to my amplitude, so it's going to be a little skinnier. It's a little like a stretch. And then to my right, I'm going to go down 3. So again, it's going to be skinnier, going down. I'm not looking for perfection, but it should look like that. So again, we know the distance as we go from negative pi over 2 to pi over 2 is pi. Again, that will change if we have a b there. That b will change it. Then we just reflect it again, okay? So just go right here, boom, go right up to here, boom, and then come down below, okay? All right, make sure you have 2 periods on each. That's a big deal. All right, last but not least, we want to talk through the cosecant graph. Now remember with cosecant, we can't necessarily just graph the cosecant right off the cuff. What we could do is know that that cosecant is related with sine, whereas secant is related to cosine. While I'm doing this, a little shout out here to David and Chris and Thomas. Hope your snow day is great. You know, just trying to be nice here. Also some shout outs. Trying to think now. Got Cam, a little shout out to Cam. Got shout out to Alex and Anna and Brooke and Emma and Emily and I could go on and on and on. All of the individuals in my class, shout outs to y'all. All right. Now, when I do this, because cosecant's related with sine, we can do the sine of x minus pi over 2, which then we would just graph what sine is. So I'm going to do this quick. So a is 1, we know. Period would be 2 pi over b, which b is 1, so it's just 2 pi. And phase shift would be c over b, which would just be pi over 2 over 1. So we know it's just pi over 2, and it's positive. Because of the sign, we push it to the right. So we'll have pi over 2 as my start. If we add 2 pi, I'll end up getting to 5 pi over 2, and we have a 3 pi over 2 in the middle. Quarter, we're good to go. So because it's the amplitude, I'm going to actually put amplitude here because it's cosecant. Amplitude would be -1 and 1, or we know it's always positive, but in this case, it'll rise 1 and go down 1. So it'll come up, touch at that quarter, right? I was a little off. It should be at that quarter. Come down, touch about right in there, right? Kind of come back through, and then I'll come back up on that way. All right, so again, that's what the sine graph would look like. And if I kept going here, I could kind of add maybe 1/2 on that side, add a 1/2 on that side, kind of come up. All right, so I can add about, actually I could do every one of the periods, but you get the idea. So that would be our sine graph. Remember, wherever I cross the x-axis, you could put a little dot there, or you could do whatever you want there. Remember, that's going to be an asymptote. So that's an asymptote, 1 there, 1 there, and 1 there, and finally 1 in here. And remember, if it's up at the top, it'll rise in between. If it's down here, it'll rise down below, rise above. Oh, that should be a little wider. I'm sorry. It's hard to sometimes draw accurate on this. Go down, and go up. Okay? Again, this was a review for the section regarding trig graphs for our test. I hope it was helpful for you. Again, if you have any questions or need details, please text me at any time or email me. I'll be glad to help out however I can throughout the course of today and maybe even into tomorrow. Hope your day is great and love you all so much. Please enjoy your snow day. Get a lot done, be productive, but enjoy it as well. See y'all.